Hello, today's segment is about percentage. Percentage is a Latin word or arrives from a Latin word percentum, which means per 100 or from 100. It is a number or a ratio expressed as a fraction of 100. That's all percentage is. So if you're doing a math test or English test, more than likely they will rate it of 100. Whether you get 100%, 75%, 90%, 60%, whatever percentage. I will show you how to set up a percentage problem to where you will continuously get it correct. I have on the board 20 is what percent of 80. 20 is what percent of 80. This percentage problem is asking you of the percentage of a number. And there are some little rules that I apply. People don't usually do it, but I find that it's so simple when I apply these little rules because I'm trying to set this problem up as a proportional problem to where I could work it so easily. A proportional problem is set up like this, where you have a fraction on this side, an equal sign in the middle, and a fraction on the other side. So this fraction is equal or proportional to this fraction. That's what a proportion is. It is set up to where the first fraction is either equal or proportional to the second fraction. So how would I set it up? The first thing I would do is I would look at the percentage. A percent is always over 100. Every single time you see percent, it is over 100. I put the percentage on the right side. And the question is 20 is what percent? They're trying to figure out what the percentage is. 20 is what percent? We don't know the percentage. That's what we are trying to figure out. So what we do is we put a variable of the unknown right there. We could put any variable, A, B, C, D, those are variables. Letters are variables. What we usually put as the unknown is the variable x. So x would represent the percent over 100. And then we have two other numbers in the equation, 20 and 80. My rule is the number that usually 95% of the times, the number that comes after the word of is the whole. So let me write something real quick. A proportional problem in a percentage is part over the whole is equal to percent over 100. This is my percentage sign. That is what a percentage sign looks like. You'll see it like this, or sometimes they write PCT for percent. But this symbol is usually used as a percent sign. And my proportional problem is always set up the part over the whole is equal to percent over 100. So my problem that I'm setting up, I have percent over 100 on the right side. And what is the percent? They did not give us the percent. So I put x over 100 to fulfill this part of the setup. And over here is the part over the whole. So we have to figure out what's the part and what's the whole. I'm not going to worry about trying to solve the problem right now. My main interest as we speak is that I show you the easiest way to set the problem up so that you can always get it correct. When you set it up and you cross cancel or reduce correctly, you'll get your answer right. So a percentage problem, to me, the best way to set up a percentage problem is set it up proportionally. You have to figure out what is the proportions. Part over the whole is equal to percent over 100. This is how you will set it up. If you apply this little rule, you'll get it right 9.5 times out of 10. You'll get your answer right. So please rewind the video, start the video back. Please go back a few seconds and look at what I have on the board. If you have to take notes, do that. If you have to look back at the video 5 times, do that. This is one of the most important parts of percentage, how you set the percent problem up. Let me talk to you about that again. One moment. Let me finish setting this one up first that I had on the board. So it's part over the whole equal percent over 100. We don't know what the percent is, so I call it x. My rule is any number that comes after off is usually the whole 95% of the times. So I trust that rule. So the whole goes at the bottom. And 20 is what percent of 80? So 20 is the part. That's how you set it up. I'm not going to solve it. I'm just going to show you how to set them up. Give me a moment. I have on the board 20 is what percent, or I'm sorry, 40 is 20% of what number. The problem I have on the board is 40 is what? 40 is 20% of what number? So I have to set it up proportionally. So the first thing I do is remember my proportional setup. Or you set proportionally a percentage problem. It's part over the whole is equal to percent over 100. This is my rule. This is my formula, my proportional formula. This is how I set up something proportionally. And it don't have to always be percentage, but I apply it to percentage and I get it right every time. Part over the whole is equal to percent over 100. So my duty is to figure out the only part they gave you in the whole formula is 100. You don't know what nothing else is. So now I have to plug in everything else. What goes where? So what I do is I set up my proportional frame. And you know what they gave you. That is known. This is always understood to be 100 all the time. No exceptions. So we try to, since I have this side, let me see if I could finish setting up that side. So it's percent. Did they give me a percent? Yes, they gave me a percent. 40 is 20%. 20%. So percent always go over 100. So all I have to worry about now is the part and the whole. There is a rule that I apply. I said if the number comes after off, the word off, that's always the whole. I look for the word off and I look for a number and there's none. We're trying to find that number. The number that comes after off, that is usually the whole. That was my rule, remember? The number that comes after off is the whole. So I don't know what the whole is. I put X. For the unknown, I put X as a variable. And then 40 is the part. And there are other ways to look at it. Why would I say 40 is the part? Because 40 is just 20% of a number. 40 is just 20%, a small amount, just 20% of the whole thing. So 40 is the part. Let me set another one up. I have a problem on the board. It asks what percent it asks what percent of 200 is 50. You see how many different ways they write the problems? So many different ways that they write it. So if you apply the formula and apply the rule, you will not get it wrong. Set the problem up is the most important part of solving a problem. How to set it up correctly. And I'm going to show you how to set it up. What percent of 200 is 50? So I apply the proportional setup. How to set something up proportionally. How do I do that? This is my proportional formula. Part over the whole is equal to percent over 100. Please remember that formula and apply it. You'll get your percentage problems right 95% of the times. So, to follow my formula, the only sure thing that's in that formula is that 100 at the bottom of the percentage sign. That's the only thing I know is sure. Everything else, I have to go to the problem and extract it from the problem. So I look for a percent. Did they give me a percent? Because I'm trying to finish this side that I already have 100 here. I'm trying to complete that side of the problem. No, they did not give me a percent. What percent of? They're trying to find the percent. They're asking you, what percent is it? They ask you straight up, what percent is it? So I do not know the percent. So the other side now, I have to find what the part and the whole is. So I apply the rule. The rule is the number that comes after off is 95% or 9.5 times out of 10 the whole. Trust it, please. It works. So what number came after off? 50 or 200? 200 came after off. So that's the whole. And 50 came after is. That's the part. This is how I would set up my proportional problem. I would not get it wrong if I know how to set it up. Let me do another one. This is so important. I'm doing them because they are very important and you need to refresh yourself on this. This is very important. I have a problem, and I appreciate you bearing with me for me writing the problem on the board. As I go along, I just hypothetically create a problem in my mind and I put it on the board. These are the type of problems that you will see on tests. I know I've taken many and I've given many. So I'm showing you the easiest way to set up the type of problems that you will see on tests. Here I have 6 students were late for school. If there are 30 students in the class, what percent made it on time? 6 students were late for school. But remember, they didn't ask you about what percent was late. You have to be very careful. They ask you what percent made it on time. How do I set my percentage problem up? I set it up proportionally. How do I set up a proportional percentage problem? How do I set up a proportional percentage problem? The formula is part over the whole is equal to percentage over 100. This is my formula. The part over the whole is equal to the percent over 100. You have to remember that. So then I set it up just like I have it here. I set it up right here. And we know that they gave us 100. It's always given. 100 is always given in the formula. So I put it back right where it is. Right where it's supposed to be. I follow the formula to a T. Please remember. And they're asking us, 6 students were late for school. If there are 30 students in the class, what percent made it on time. They want to know what percent made it. We don't know what the percent is that made it. So we are trying to find percent. Percent go over 100 and we don't know what it is. So we make it a variable. I call it X. And the other side is the part and the whole. And they said that 6 students were late. There are 30 students in the class. There are 30 students in the class. That's the total amount. That's the whole amount of students in the class. So that's the whole. So I put it right here, where the whole goes, at the bottom. And the top is the part. Most of us, if we don't pay attention, will get this wrong, because now we are going to put 6 at the top. But 6 is the wrong number to go there. Why is 6 the wrong number? Because 6, they are the amount that were late. They didn't ask you for the percentage that were late. The question is, what percent made it on time? What percent made it on time? So first you have to figure out how many students made it. If 6 were late, there's a total of 30 students. 24 made it on time. 6 were late. So 24 made it on time. We're trying to find out the percent that made it on time. 24 out of 30 made it on time. Please, this is so very important when it comes to percentages. To me, this is the most important part of a percentage problem. How to set it up. If I have 20 percentage problems, 18, 19 of them I could set up like this. I will show you the simplest way to solve it after I set it up. But before I could do that, I want to make sure that you are setting up the problem correctly. So bear with me, please. I'm trying to set this thing up so that you will get it correct 9 times out of 10. That you will shine when you take your test if you just follow the methods, follow the formulas, follow the rules, trust them, know your timetables, and you cannot go wrong. You'll get it right 95% of the time. Here's a very simple problem. 20% of 60. 20% of 60, I could just put 20 over 100 times 60, because half means to multiply. Remember, half, product, all times, these mean multiply. Half, product, time. What is the product of 6 and 4? Product means to multiply. 6 times 4 is 24. Or they would say 6 times 4. Same thing. Okay, so 20% of 60, that's 20 over 100 times 60. But I wouldn't set it up like that. Yes, me, I would do it quick and get it right. But I'm going to show you how to stick to your proportional problem so you will get it right using the same formula, the formula at all times. So even a simple problem like this, I just make it my habit to follow the formula. What is the formula? The formula is part, oops, just 1 second, part over the whole is equal to percent over 100. The formula is the part over the whole is equal to percent over 100. You'll do it so many times until you remember the formula straight off the top of your head. Part over whole is equal percent over 100. That is the proportional problem. That's how you set up a proportional percentage problem. Part over the whole is equal to percent over 100. So I substitute everything that they gave me here as the formula, and I put my numbers where they go. How do I set this up? I know for a fact they gave me 100 in the formula. I put it down. Did they give me a percent? I'm going to complete this side first. Yes, 20%. 20 goes over 100. So what do I want to put here? The part over the whole. Is 60 the part or is 60 the whole? Remember the rule. The rule says the number that comes after off is the whole. So I trust the rule. So 60 goes here, and I'm trying to find the part, and whatever part of the proportional setup I do not have, I create the variable for that place. This is how you set it up. I will get this right closing my eyes. I'm just going through the various ways they write percentage so that you'll see that they come at you in so many different ways. The question here is 600 is 20% of what number? 600 is 20% of what number? Threw you for a loop. The first thing I want to do is put my proportional setup. What is it? Part over the whole is equal to percent over 100. That is my formula for my proportional percentage setup. Please remember it. Please learn it. Please apply it. You'll get the problem right every time. So now 600 is 20% of what number? How would I set that up? I know they gave me 100. Did they give me a percent? Yes, they gave me 20%. Percent go over 100. This part of the formula is set up. Now I have to set up the part over the whole. What is the whole? Most of us would jump and put 600 as the whole. It's such a big number. But you have to be careful because 600 is 20%. 600 is not 100%. 600 is 20% of the whole thing. So 600 is just a part of the whole thing. It's just 20%. 600 is not 100%. 600 is 20%, just a part. So 600 is the part. And we are trying to find the whole. So I put a variable x. So let me start working these problems right now. When you have, I'm going to put two problems here. Remember we talked about fractions, multiplying fractions. And you have, for example, 2 over, you have, for example, 2 over 3 times 9/10. And I said that when you have a multiplication problem, you could cross cancel going this way or cross cancel going this way, or you can reduce straight up and down. If this can be reduced, I reduce it. If this can be reduced, I reduce it. But it cannot be reduced. But I can cross cancel because 3 can go into 9 evenly. 3 into 3, 1. 3 into 9 goes 3. And 2 can go into 10 evenly. 2 into 2, 1. 2 into 10 goes 5. That's how you multiply fractions. But with a proportional problem, it's a little different. You do not have a multiplication sign in the middle. You do not, I repeat, you do not have a multiplication sign in the middle. You have an equal sign. So it's set up like this. And when you have an equal sign, not multiply, when you have an equal sign in the middle, you can cancel across the top, across the bottom, or straight up and down. Remember that. So I could use this 0 and cancel this 0. Very simple. I could also put this 2 into 60, goes 30. But I cannot cross cancel because it's not a multiplication sign. So I cannot cross cancel. I could cancel across the top, across the bottom, or up, straight up. Remember, these are little rules that you apply, little tricks of the trade. You remember them when you're taking a test and apply them, because you move faster and you get the answer right. So x times 1 is x, equals 30 times 100 is 3,000. So 600 is 20% off what number? 3,000. I have a problem. What is 40% of 250? What is 40% of 250? My problem or proportional setup is part over the whole is equal to percent over 100. That's my formula. So I just plug in these places. 100 is given to me already in the formula. Did they give me a percent? Yes. Percent always go over 100. The percent always go over 100. What number is the part and what number is the whole? The number that comes after off 95% of the time is the whole. Here's the number after off. 250 is the whole, and we're trying to find the part. That's the setup. I'm moving faster now. You should be catching on to it. If I have an equal sign in the middle, I could cancel across the top or across the bottom. That's what an equal sign says. I could cancel across the bottom, or I could cancel across the top, or I could cancel straight up and down, which reduces it. So 50 can go into this how many times? 4, 8, 2, 4, 5 times. 50 go into 255 times. 50 go into 100 2 times. 2 into 2 goes 1 times. 2 into 40 goes 20. There's no more cancelling. So I cross multiply. 1 time x is x. Bring down my equal sign. 5 times 20 is 100. So what is 40% of 250? 100 is 40% of 250. The question is 20% of what number is 80? 20% of what number is 80? My proportional setup. You don't have to keep writing that down. You don't. I'm just doing it so that we just get used to doing it and used to seeing it, so we just remember it every time we see it. Part over whole is equal percent over 100. So this is the setup. That's the only thing that's given, the 100. Did they give me a percent? Yes, 20%. Always go over 100. What is the part and what is the whole? 20% of what number is 80? So 20% of a number is 80. So the number is not 80. 80 is just 20% of that number. We want to know what the number is. So the whole part is x. And the whole is x and 80 is the part. Can I cross cancel across the top? All day long. 20 into 20 goes 1, 20 into 80 goes 4 times. Remember that. When you have an equal sign, you can do that. Practice it. It works. And you get it right every time. So, there's nothing else for me to cancel. I cannot cross cancel. This is not multiply. Only when you have a multiplication sign you could do that. So what I do now is I cross multiply. 1 times x is x. Bring down my equal sign. 4 times 100 is 400. So 20% of 400 is 80. Wow. Now look at this problem. It's a little strange, but you will see it every now and then. What percent of 200 is 400? It looks weird. I'm going to show you why. We know the formula. The formula is part over the whole is equal to percent over 100. That's the formula. I follow my formula. The only thing they gave me was 100. What go over 100%? What percent of 200 is 400? They did not give me the percent. They're trying to find what percent is it. So I call that percent x. And trust the rules. Even although you have 200 and 400, 400 is not the whole. The number that comes after off 9 times out of 10 is the whole. Here is the number that comes after off. Apply the rule. So the whole is 200 and the part is 400. It looks weird. It looks weird, but that's actuality. That's how it's set up. So now, can I cancel? I could cancel. I could reduce 200 into 201. 200 into 400 goes 2 times. I could cancel across the bottom. 100 into 200 goes 2 times. There's so many different things I could do. That's the easiest thing. 1 times x is x. Bring down my equal sign. 2 times 100 is 200. So what percent of 200 is 400? So actually 400 is 200% of 200. If 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 I had used 400 as the whole and 200 as the part, if I had used 400 as the whole and 200 as the part, I guarantee you the first answer on the test would give you that. Whatever I get from that, that would be the first answer. For example, one time x is x equal 50. The first answer on the test will be 50. The first answer on the test will be 50. You get it wrong every single time. You get it wrong every single time. You follow the rule. The number that comes after off is the whole. I have 6.5% of what number is 30? I know that they gave me 100 in the formula. Part over whole is equal to percent over 100. 100 is always given. Did they give me a percent? Yes. 6.5. I could change it from 6.5 to 6.5 because I know that 1/2 is also 0.5. 1/2 is also 0.5. There are so many different ways to do this, but I'm going to show you the easiest and the quickest way to do it. So I changed 6.5 to 6.5. 0.5 percentage go over 100. And 6.5% of what number is 30? They want to know what number. 30 is 6.5% of what number, basically. So the whole is x and 30 is the part. Let me say something to you, and this is so important. When you're doing percent is of 100. We know that. That's what we've been doing. We talk about it from the get-go, from the beginning. I explained to you what a percent is, what a percentage is, and it's from 100, a ratio or a fraction of 100. When you're multiplying and dividing by 100, all you have to do is move the decimal place. Let me explain. I have 14.21 times 100. This is also showing to be multiplication. 1 second. Multiplication is written like that sometimes. When you have two parentheses beside each other like that, it means multiply. Remember, when I'm multiplying by increments of 10, 100, 1,000, 10,000, 100,000, and so on and so forth, however many zeros you have, that's how many places you move the decimal. So 14.21 times 100, I move the decimal place 2 places. 1, 2. So my answer is 1421, 1421. If I have 0.215 times 100, all I have to do is move the decimal how many places, how many zeros I have in my increments of 10. This is 100, so it has 2 zeros, so I just move the decimal place 2 places. When you're multiplying, the decimal place goes to the right. When you're dividing, the decimal place goes to the left. In this case, I move it 2 places. My answer is 21.5. You have to trust it. If I have 10 times 6.21, 10, it has 1 0. I move the decimal place 1 place to the right, so it becomes 62.1. Please remember that. So here, if I'm dividing, the same thing applies. 6.5 divided by 100 is increments of 10. It has 2 zeros, so I move the decimal place instead of to the right, like when I'm multiplying, that's the only time I move it to the right. When I'm dividing, I move it to the left. How many places do I move it? 2 places. I only have 1 place, so I have to create a place. So 6.5 divided by 100 is also 0.065. Please remember this. This is very important when it comes to percentage. It's so important when it comes to percentage. So here, this divides into this is dead, and this moves 2 places, so this becomes 0.065. And now I have x times 0.065 equal 0.065x. Bring down my equal sign, and 30 times 1 is 30. When you get this far, in any equation, you divide both sides by the number in front of the variable. That's an algebraic equation rule that we have to apply here, and I'll show you that rule when we get to algebra. But when you're working a problem and you get this far in any equation where you have a variable, the variable x, y, z, whatever the variable is, and you have a number in front of it, you're trying to figure out what the answer is. You divide both sides by the number in front of the variable. So 0.065 into 0.065x leaves you with x, and 30 divided by 0.065. Now you have to know how to divide decimals. You cannot divide by a decimal. You have to get rid of it. How do you get rid of it? You put the decimal place behind the last number. We did that in the last segment, decimals. So if you need to refresh yourself, go back and look at the last segment I did, which was decimals, and also go back and look at the segment before that, which was the first segment, which was fractions. It shows you how to do it, how to divide by a fraction or how to divide by a decimal. Remember, I said you cannot divide by a decimal. So this is actually this. 30 divided by 0.065. I have to get rid of the decimal by moving it to the last number. In this case, I move it 3 places to get behind the 5. 1, 2, 3. However many places I move it on this side, I move it the same amount of places on that side. Where is it here? This is a whole number, 30. It's understood that the decimal is behind the whole number. It's right here. So I move it 3 places. There are no places there. So I have to create places. 1, 2, 3. 1, 2, 3. So now I have actually 30000 divided by 65. Let's try 4. 4 5 is 20. 4 6 is 24, and 2, 26. Oh, no, that's wrong. I bring down my 0. What do I try now? Try 6. Let's try 6. 5 6 is 30. 6 6 is 36 and 3, 39. Let's carry down to 0. I try 1. 1 times 65 is 65. Add a 0. 5 5 is 25. 5 6 is 30. Try 5. 5 6 is 5 5 is 25. 5 6 is 30. 31 32. So basically, it's going to be 461.5, and it's going to keep going, 0.53 or something to that effect. But this would basically be what my answer would look like, 461.5. Let me see what it will carry to. 3 5 is 15. 3 6 are 18, 19. 5 from 10 leave 5. 9 from 14 leave 5. Okay, so that would be 461.53. Know your timetables, and you know how to divide, and you know how to multiply. But it's a rare case that you'll see you'll have to do a problem that you have to do such a long division to get the answer. Very rare. You'll very rarely see that. So don't panic. Apply your formula. Apply the rules. The formula is part over the whole is equal to percent over 100. And the rule is the number that comes after off is understood to be the whole. And percent go over 100. Remember those rules and you'll get it right every time. These are the different ways that they will come at you with a percentage problem. 10% of 60, just an example, hypothetically speaking. You might see 4% of 200. You might see different forms, but this is one form of how they will come at you. 10% of 60, that's one problem. Then another problem, they will come, for example, 20 is what percent of 200? They changed it up a little bit. So all these are set up differently. And here you have 6% of what number is 20. So how do I set these up? Remember, part over the whole is equal to percent over 100. I'm going to set each one up. The first one, part over the whole is equal to percent over 100. Did they give me a percent? Yes. What is the percent? 10. And what's the whole? Of 60. 60 came after of. That's the whole. Trust the formula. Trust the rules. And we're trying to find the part. X over 60 equal 10 over 100. That's the setup. That's number one. Number two, part over whole is equal percent over 100. The question is, what is 20 is what percent of 200? 20 is what percent of 200? They're trying to find the percent. So we don't know what the percent is. We call it a variable. I call it x. Numbers are variables. A, B, C, D, E, F, G, all the way through Z. They are variables. You could call them, or you could call each one whatever you want. I am just used to calling the variable x. We are trying to find the percent. So the next part is the part over the whole. What is the whole? The whole is 200 because it came after off. That's my reason. You can look at it to tell or to figure out why 200 is the whole, but I just follow that rule. It comes after half, it's the whole. And 20 is the part. And number 3, 6% of what number is 40? 6% of what number is 40? Did they give you a percent? Yes, 6%. Of what number? You don't know what number came after of. Of what number is 40? So we're trying to find the whole, and 40 is the part. Wow, so simple. 0 cancels 0. I can reduce up and down. I can go across the bottom. 0 cancels 0. So here I have 6 times 1 is 6. 1 times x is x. So x equals 6 for the first one. The second one, 100 into 101, 100 into 202, 2 into 2, 1, 2 into 20 goes 10. So 1 times x is x equals 10 times 1 is 10. So the first answer is 6. 10% of 6, or 10% of 60 is 6. 10% of 60 is 6. The second one, 20 is what percent of 200? 20 is 10% of 200. And the third one, okay, 2 into 6 goes 3 times, 2 into 40 goes 20. There's nothing else to cancel, so what I'll have to do is I'll have to cross multiply. 3 times x is 3x is equal to 20 times 100 is 2,000. When I get this far in any equation to where it cannot be reduced and I have the variable as a mixed variable because I have a number in front of it, which is the whole number 3, I have 3x, it's a mixed variable, I will never leave my answer like that. I don't want to know what 3x equals. 3x equals 2,000. That's not what you try to solve for. You don't try to solve for what 3x or 4x or 5y is. You always want to know what the variable is by itself. What is x? What is x? So I divide both sides by the number in front of the variable. 3 into 3x goes x equals 3 into 2,000 equals what? 3 into 20 goes 6. 666.66. That's basically what you're going to get. The answer is 6% of what number? 666.66. And I always stop at the 100th place after the decimal. If they say round it off to the 10th place, then I round it off. This will be 666.67. I showed you how to round off a number in my last segment. As I go forward, mathematics will be getting a little more difficult. This is percentage. We are doing percentage. The one before this was decimals, and before decimals was fractions. So as you go a little further, it's going to get a little more difficult. So here we are doing percentage, and the next segment, more than likely, would be either simple interest, or I would go into mean, median, and mode, or ratio and probability. But I will be moving on from percentage. You need to remember the steps. I'm going to do just a couple more. Then you will be able to look back at what I showed you. Try to remember the different rules. Try to remember the formula. Trust it, know your timetables, and you cannot go wrong. Okay, so what is a percent? A percent is a number or a ratio written as a fraction of 100. That's what a percent is. And when you have a proportional or a percentage, when you have a percentage problem, the easiest and quickest way to do the percentage problem is to set it up proportionally. Set it up proportionally. What is the proportional formula? Let me repeat this. What is the proportional formula for a percent or for percentage? It's part over the whole is equal to percent over 100. That is your formula. If you stick with your formula, you will not go wrong. And read your questions correctly, because they will try to trick you. Okay, excuse my writing, please excuse my writing. I'm kind of rushing and I don't write so pretty anyway, so excuse my writing, please. Let me read it for you. 40 people, 40 people were affected by the weather. If the total number of people is 200, what percent was not affected by the weather? This is the tricky way they will come at you in a percentage problem. But we know if we follow the formula, apply the rules, set it up, we are going to get it right. The rule is, or the formula, part over the whole is equal to percent over 100. That is my proportional percentage setup. Part over the whole is equal to percent over 100. So I look at my percentage problem. 40 people were affected by the weather. How do I know it's a percentage problem? They asked me, if the total number of people is 200, what percent was not affected? They didn't ask you what percent was affected. They asked you what percent was not affected. Please, 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 you have to pay attention to that, because the first answer on the test would be the amount that was affected. That's the first answer. And a lot of us are going to jump on it and they see that answer and you can't tell them that they didn't get it wrong. But they did. They got it wrong. So let's set it up. We know the only thing they gave us was 100. What go over 100%? They ask us what percent was not affected. We are trying to find the percent. We don't know what the percent is. Oops. So I call that X. I'm sorry. I call that a variable. And here I have the other part of my percentage problem, which is the part and the whole. What is the part and what is the whole? 40 people were affected by the weather. If the total number of people is 200, the total number is the whole. That's the whole amount, the total amount. The total is always the whole. So 200 is the whole, and they want to know what percent was not affected by the weather. We're not going to put 40 on top. Why? Because 40 is the amount that was affected. We want to find out the amount that was not affected. So I take 40 from 200, leave me with 160. 160 is the amount that was not affected. That's the percentage I'm trying to find out. What percent was not affected? 100 to 101. 100 into 200 goes 2 times. 2 into 2 goes 1. 2 into 160 goes 80. There's no more cancelling to do. Cross multiply. 1 times x is x. Bring down my equal sign. 1 times 80 is 80. So 80% of the people were not affected by the weather. Only a small 20% were affected. 80% were not affected by the weather. You could rewind the video, please, so you could look at this problem again. Try to figure out why I said that 40 is not what we're looking for, and try to apply it. Give yourself some problems, and please, if you have any questions, look at the comment section below and write as many questions as you would like. And I hope you enjoy this segment. This segment is all about percentage, how to how to set up a percentage problem by using a proportional setup. How to set up a percentage problem by using a proportional setup. Part over the whole is equal to percent over 100. I also showed you the easiest way to multiply or divide by increments of 10, 100, 1000. If you have 1.46, 1.46 times 100, 1.46, since it's 100 has 2 zeros, I just move the decimal place 2 places to the right. When I'm multiplying, I move it to the right. When I'm dividing, I move it to the left. I thank you for watching this segment. I hope you enjoyed. Again, thanks. I thank all essential workers, and I thank all first responders. I call them the frontline workers, but first responders, thank you. I thank the medics. I thank the ambulance drivers. I thank the firefighters. I thank the police officers. I thank the delivery individuals. I thank all of you. I thank the essential workers, hospital workers, the nurses, the doctors, the techs, the medics. I thank every last one of you. Thank you so much. The next segment will be day after tomorrow. I'll post this one later on today, and I hope you enjoy it. Thank you.